Hey guys, so we are going on to our next section. We are going to talk a little bit about parallel lines, different relationships between lines, and how they can form different angle relationships. So I'm sure you already know the definition of two parallel lines, but just to have it down again, two lines are parallel if they do not intersect. So they are two lines that do not intersect. Okay, something we can pull in from our geometry vocabulary is if we have parallel lines are always coplanar, so they are also coplanar. When we see parallel lines, just as an example, say this is line AB and line CD. We would say that line AB is parallel to line CD. So this double line here means that those lines are going to be parallel. Skew lines, I'm not sure if we've ever really heard them, but skew lines are still two lines that do not intersect. But they're not in the same plane. So they're not coplanar. Okay, it's a little bit harder to draw out in like a 2D drawing. But if I have a little box here, okay, let's say this is line AB here on the bottom. This line up here would end up being, we can label it CD. So line AB here would be considered to be skew to line CD. You can see how they're not really headed in the same direction, but they're also they're not on the same plane and they're not going to intersect. So no, they don't have to go in the same direction, but they're also just never going to intersect. When we talk about parallel planes, I'm sure you guys can imagine it's similar to parallel lines. They are just two planes that never intersect. Okay. Unlike parallel, there's no real symbol to represent skew lines. And when we talk about parallel planes, we can still use that same symbol there. When we talk about perpendicular lines, again, I think you guys have heard this before, but two lines lines are perpendicular if there are two lines who intersect and their intersection forms a right angle. Okay, so if we have perpendicular lines, right? Say this is line AB, say this is line CD. These lines would be considered perpendicular if they form a right angle. And in order to show that, we would say line AB is perpendicular to line CD. So you guys can kind of see from my diagram where this symbol comes from. So anytime you see that upside down T, that means that the lines are perpendicular. So from our diagram below here, we can see that lines M and N are parallel. You can also check from a diagram if you see those double arrows. You have the arrows at the ends here. If you have the extra arrows in the middle, that also means that the lines are parallel. From this diagram, it's maybe a little bit easier to see that line K and line M, they're skew lines, right? They're never going to intersect, but they're also not contained on the same plane. They're headed in different directions. So they're not parallel, but they're still just never going to intersect. We can see plane T and U are our parallel planes here. And lines K and N, they're intersecting lines. But unless we saw like a right angle box here, we wouldn't be able to assume that they're going to be perpendicular. Okay, so they're just considered to be intersecting lines. There's no special relationship between them. Okay, so in this first example, it says, think of each segment in the figure as a part of a line. We want to know which line or plane in the figure appear to fit the description. So on letter A, we want a line that's parallel to this line CD that also contains point A. So there are plenty of lines here that are parallel to CD, but there's only one line that contains point A that's also parallel to CD. That would be this line here, AB. Okay, so AB would be a parallel line that contains point A. If we didn't have this part about it having to contain point A, we could have said that EF was parallel to CD, HG is parallel to CD, and then of course AB is. When we look at B, where it says lines are skew to the line CD, again, skew means that they're going in opposite directions or different directions, but they're never going to intersect, and they're not on the same plane. So there's 3 different skewed lines here. One skewed line here would be this line AH, right? That contains point A, so we can write that as our answer. Another skewed line would be this line AG, right? Again, they're never going to intersect. They're on different planes. And the last skew line that it doesn't necessarily contain point A, but it's still skew to CD, would be this line BG, right? So it doesn't contain point A, but BG would also be considered to be skew to CD. When we're talking about perpendicular lines, again, there's several perpendicular lines to CD, but the one that we're looking for has to contain point A. So that line here, this line AD, would be a perpendicular line that contains point A. Again, there's a couple of different lines that don't necessarily contain point A that are perpendicular. So we could have said BC, BC, we could have said CF or ED. All of those would be considered to be perpendicular, but the only one that contains A is AD. And then the plane that's parallel to plane EFG, and if you notice, EFG is your bottom plane. The only plane in the diagram that is parallel to this is the top plane. And that top plane has to obviously contain point A, but our top plane, you can label it with 3 or 4 letters. I'm going to list it with 4 just so I hit all 4 vertices, but plane A, B, C, D would end up being parallel to that bottom plane. Okay, so I want you guys to take a second. I want you guys to pause your video. I want you guys to try this practice problems on your own, and then when you try them on your own, you can press play again and we can go over them together. Okay, so hopefully you guys had pressed pause and you guys did all of these out. Our directions on these, it says, think of each segment in the diagram of a rectangular box as part of a line. Which lines or planes contain point N and appear to fit each description? So we're looking for it has to contain point N. So on number 1, a line that is perpendicular to QR, again, so it intersects to form that right angle. Here's QR, the line that intersects and forms a right angle would be this line NR. Okay, a line that's parallel to QR that contains point N would be this line NP. A line that's skew to line QR that contains point N would have to be this line NJ. And then lastly, the plane that's parallel to plane LMQ, which is this right plane, this little darker plane here. The plane that's parallel to this plane that contains point N would be the plane on the left. So it would be plane, we can call it NJK, or we can say NJKP. It doesn't matter whether you list the planes with the 3 or 4 letters. Okay, so that was kind of getting our basic definitions of parallel, of perpendicular, of skew, how we use those in regards to lines and planes. Now we want to talk about angle relationships. So when we talk about these angle relationships, it may seem unrelated to what we just talked about with the parallel, perpendicular, and skew. but the next few sections after this is actually going to connect them together. So let's start off talking about angle relationships. The first thing we need to define is a transversal. A transversal is a line that intersects two other lines. And that intersection forms 8 different angles. So it's a line that intersects two other lines to form 8 different angles. So it's kind of written small on your paper. I know it looks probably a little bit better on the screen, but I'm going to write down this example here. Okay, this is the type of diagram we're looking at. So going back to the definition of a transversal, right? The transversal is a line that intersected two other lines, which you see here, and they form 8 different angles, which I labeled. So we have 4 different angle relationships that are formed here. So we've already talked about angle relationships in regards to adjacent angles, vertical angles, linear pair. We're kind of still going to talk about those, but we're kind of getting away from those here. So the first type of angle relationship we're going to talk about are corresponding angles. And if you think about the word corresponding outside of a geometry context, right, corresponding means they kind of go together, right? They're the same, they're similar, right? So corresponding in this diagram, basically an example would be angle 1 and angle 5. So if you were to split up this diagram where the top angles were one group and the bottom angles were another group, angle 1 and angle 5 are both in that top left position, right? Another example would be angle 3 and angle 7. Those would be corresponding angles. Again, they're in like the same position. They're in the bottom left. So for corresponding angles, our example from this diagram would be angle 1 and angle 5. We would also talk about angle 3 and angle 7, as we said. Angle 2 and angle 6 are also corresponding. And angle 4 and angle 8 are also corresponding angles. So those are all of our corresponding angles. We talk about these relationships in regards to pairs. We're looking at pairs of angles. The next type of angle relationship we want to talk about is alternate interior angles. So alternate, again, thinking of it outside of a geometry context. Alternate is kind of like opposite, right? Or another option, right? So if we think about it in that way, and we think about the word interior, right? Interior means inside. We're looking at opposite inside angles. The opposite refers to which side of the transversal it's on, right? So this line here, if we remember, this is our transversal. So you can either be on the left side of the transversal or the right side of the transversal. The inside, the interior part of this, means you're inside of the two lines here. So we're looking in the interior. So alternate interior angles would be like angles 4 and angle 5. They're on opposite sides of the transversal, but they're in between the two lines. So an example would be angle 4 and angle 5 are alternate interior angles. And another example would be angle 3 and angle 6. Those are also alternate interior angles. And similarly, when we're talking about alternate exterior, right, alternate still talking about the opposite. Exterior means outside. So now we're outside of those two lines, right? We're up here or we're down here. So alternate exterior angles, an example would be angle 1 and angle 8. That would be an example of alternate exterior. Another example would be angle 2 and angle 7. So those would be our alternate exterior angles. And the last one we see are consecutive interior angles. So consecutive, if we think of it, again, outside of geometry class, consecutive means like one after the other, or right, like the same side or something. So consecutive interior angles, you will sometimes see written as same side interior angles. Okay, and a lot of the times I'm going to refer to consecutive angles as same side interior angles. That's just how I'm going to label them. So when we talk about same side interior, we're on the same side of the transversal and we're inside the two lines again. So angle 3 and angle 5 are same side interior angles, and angles 4 and angle 6 are same side interior angles. Okay. Again, take a second, pause your video. I want you guys to try example 2 on your own, listing out the different relationships. So take a second to pause your video, and when you have all your answers there, then you can hit play again. Okay, so hopefully you guys had tried these out on your own. So for letter A, if I'm looking at corresponding angles, we want to identify all the different pairs that are given here. So based on this diagram, the first example we could talk about for corresponding angles would be angle 1 and angle 5. Those would end up being corresponding angles. Angle 2 would also correspond with angle 6. Angle 3 and angle 7 would be corresponding angles. Oops. And then lastly, angle 4 and angle 8. So all 4 of these pairs here are examples of our corresponding angles. For our alternate interior angles, our first example would be angle 2 and angle 7. And our second example would be angle 4 and angle 5. Okay, only 2 pairs there because there's only 4 4 interior angles. Okay, alternate exterior angles. One example could be angle 1 and angle 8. And the second example could be angle 3 and angle 6. So again, only 2 examples here. Oops. Only 2 examples here because there's only 4 exterior angles. In the last one, consecutive interior, or again, we can label that as same side interior. One example would be angle 2 and angle 5, and the other example would be angle 4 and angle 7. Okay. On the next example here, it says identify the transversal and classify each angle pair. So the first thing we need to do is we're looking at angle 1 and angle 5. When we compare these two angles, right, over here doesn't necessarily matter to us. It's not affecting the relationship. So I'm going to go over that, right? I'm going to block that section off. That makes it a little bit easier to see that my transversal here is the line that's going to cross through both of those lines that contain 1 and 5. So my transversal here is N. N is my transversal. Okay, and when we look at this, they're in the interior of the two lines and they're on opposite sides of that transversal. So these would be alternate interior angles. And you'll see I just kind of shorten it a little bit here. Okay, so that was letter A. Going to letter B, if I'm looking at angle 3 and angle 6, we're looking at these angles here. Now over here doesn't matter to us, right? It doesn't matter what's happening over here. We're only worried about angle 3 and angle 6. And again, if you cover this section up, it makes it a little bit easier to see that line M is my transversal. It's that line that cuts through both of the lines containing angle 3 and 6. Okay. Also looking at 3 and 6, they're on the same side of my transversal, but one's on the interior, one's on the exterior. This is going to be a corresponding pair. Okay. And then lastly, we need to look at, we're going to look at angle 1 and angle 4. Okay, so again, now this section down here doesn't matter to us. So it makes it a little bit easier to see that line L will be my transversal. Okay, again, looking at the relationship between angle 1 and angle 4, they're on opposite sides of this transversal, and they're also considered to be on the exterior of these, the lines here. So angle 1 and angle 4 are considered alternate exterior angles. Okay. So once you have that down, again, take a second, go to the bottom of this page, and I want you guys to pause the video, take your time, try the 13 practice problems here. And when you finish, you can hit play again and we'll go over them together. Okay, so hopefully you guys have already paused it and took some time to go over this. On number 1, it says, blank are located on opposite sides of a transversal between the two lines that intersect the transversal. And we can fill that in with either corresponding alternate interior, alternate exterior, or same side interior angles. So if they're located on opposite sides of a transversal, automatically we can get rid of corresponding and the same side interior angles, right? Those are all on the same side of the transversal. So we're looking at alternate interior or alternate exterior. Because they're between the two lines, that means inside, we're looking for alternate interior angles. So our blank here should be filled in with alternate interior angles. Okay. On number 2, there's a lot of different examples from the diagram here. If I wanted to look for a pair of perpendicular segments, what I said is that line EH and line DH are perpendicular, right? We know that by the little right angle box. But again, there's actually quite a few different segments you could have chose. You could have said CD and GC. You could have said BF and EF, right? So any of those would also have been perpendicular. There's plenty of other examples as well. One pair of skew segments, I had mentioned that AE, that line AE here, is going to be skew with the line HG. Okay, and again, so many different examples there. That's just the one I had chosen. A pair of parallel segments, you can see your little arrows up here. So that's a hint. You can use those. So line AB and line DC are parallel to one another. Again, you could have said AE and DH. You could have said CG and BF or any of those, right? There's actually quite a few different parallel lines in there. Oops. And then one pair of parallel planes, multiple examples. I'm just going to choose the top and the bottom. I said ABCD and EFGH. Those are parallel planes there. You could have done the left and the right sides. You could have done the front and the back. I just chose the top and the bottom. On number 6, it says, give an example of each angle pair. On number 6, a pair of alternate interior angles. I chose angle 1 and angle 3. You could have also chosen angle 2 and angle 4. A pair of alternate exterior angles. I chose angle 5 and angle 7. You could have also chosen angle 6 and angle 8. My corresponding angles, I chose angle 6 and angle 3. You could have chosen angle 2 and angle 7, angle 5 and angle 4, or angle 1 and angle 8. There was a bunch of different options on that one. And then same side interior angles, I said angle 1 and angle 4. You could have chosen angle 2 and 3 as well. And then this last example is very similar to one we had done above. We wanted to identify the transversal and then classify each angle. On looking at angle 1 and angle 2, our transversal is line N, and those are corresponding angles. Okay, angle 2 and angle 3, looking at these angles, M would be our transversal, and those are going to be alternate exterior angles. Angle 2 and angle 4, the transversal here would be line N. Those are going to be alternate interior angles. And angle 4 and angle 5, your transversal will be P, and those are same side interior angles. Okay, so again, I know maybe the first part of it doesn't necessarily seem to connect to the angled relationships that we talk about in the last half of this. But the next two sections will probably we'll squeeze them into one note packet. It'll make connections of why we're talking about parallel lines and the relationships of these angles. Okay, so your work for right now, if you finish this before class ends, your work for right now is to do page 142 through 143, numbers 3 through 31 on. Okay, and as always, you can do all for extra credit. Okay, so that is posted up on Google Classroom. Hold on to this work. So when you finish, if you finish early, certainly take the time and do your extra credit. It's not going to take that much longer. But hold on to this work and I will go over it and I'll talk about it the next class, the next time we meet.